For centuries, when humanity looked through a telescope at Saturn, we saw a serene, static monument. From this far out, the rings look like perfectly solid tracks of vinyl orbiting a gas giant. But that peaceful solidity is a complete optical illusion. It's a trick played on our eyes by the immense distances of the outer solar system. This vector model illustrates the horizontal scale we're dealing with. If you laid copies of Earth edge to edge across the main rings, you could fit 23 of them in a perfectly straight line. Yet, despite spanning hundreds of thousands of miles across, the physical thickness of this structure is almost nothing. From top to bottom, the main rings are extremely narrow. You could easily fit the entire vertical height of Saturn's rings inside a single human skyscraper. A structure this wide and this thin faces immense internal stress. The intersections must orbit significantly faster than the outer edges to stay aloft. Maintaining this razor-thin profile across such a distance creates a massive mechanical puzzle. To figure out how this impossible structure actually holds together, we have to abandon our standard macro view of the solar system and look at the physical reality much closer. When you transition the perspective directly into the ring system in high resolution, the illusion of a unified disk disappears, replaced by distinct, separated bands. You're looking at a chaotic, fast-moving river composed of billions of individual fragments of water ice. These icy fragments range wildly and unpredictably in size. Some are tiny as sand grains, others are massive, mountain-sized chunks, all colliding and tumbling in orbit. The reason they are trapped here comes down to a gravitational boundary called the Roche limit. This is the specific distance where tidal forces pulling an object apart become stronger than the internal gravity holding it together. Long ago, an ancient moon wandered past this boundary. Saturn's intense pull stretched and warped the moon until it violently ripped apart into debris. Over deep time, millions of years of gravity and collisions slowly flattened that chaotic cloud of shattered ice along the planet's equator, settling it into the synchronized orbital dance we observe today. The most beautiful feature in our solar system is actually a cosmic graveyard, the lingering remains of a destroyed world. Remote telescopes back on Earth could theorize about these microscopic mechanics, but they couldn't physically weigh the ice to prove it. For that, scientists needed an instrument capable of physically entering the hazardous debris field. That complex engineering solution was the Cassini spacecraft, designed specifically to map this harsh microscopic environment. This cross-section outlines its daring final maneuvers. The team piloted Cassini into the incredibly narrow gap between Saturn's upper atmosphere and the rings. By flying underneath, Cassini isolated the gravitational pull of the ice, allowing scientists to measure the rings' total mass. The measurement revealed a shocking result. The rings possessed far less mass than previously assumed, which proved they were formed much later than Saturn itself. Cassini's physical dive provided the hard data to move the rings from the realm of abstract mystery into a measurable, solved mechanical system. But that precise data brought one final, sobering discovery. The ring system is actively bleeding out and degrading. As those billions of icy fragments constantly crash into one another, they lose their orbital velocity. The decelerated ice is then caught by gravity and magnetic forces, creating a constant downpour where particles fall into the planet, a process known as ring rain. Math dictates an inevitable consequence for this rate of decay. Saturn's rings are a temporary phenomenon. Eventually, the material will deplete, and the rings will vanish completely from the solar system. When you compare the immense timeline of the universe against the brief span of human history, it exposes profound cosmic luck. We evolved and built telescopes at the exact moment this massive icy halo was actually visible. These rings are a temporary feature, a brilliant, fleeting reminder of the finite nature of the universe.